begin. Since mensuration questions are a lot about formulas, what I want to do at the start of the class, and I think this is going to take the entire class today, is to take you through all the shapes that are there, that come up, and the formulas are used, and so on. So let's go through all of that, and then we'll start attempting questions. 2 dimensions, we're getting 3 dimensions as the questions come up. Okay. The first shape that I've drawn is a parallelogram. Okay, a parallelogram is made up of 2 pairs of parallel sides. Okay, इसमें से कुछ एंगल प्रॉपर्टीज में भी यूज होंगे, तो मैं अभी से एक साथ करा रहा हूँ ताकि बाद में भी यूज हो. 2 pairs of parallel sides. Parallel को इस तरह लिखते हैं, सही है. I've written with that. सही है. Then opposite angles are equal. Let's first talk about opposite sides. पहले opposite sides की बात करें, फिर angles बात है. Opposite sides are equal. Opposite angles are equal as well. Neeraj, can you keep your mic on mute, please? Okay. And diagonals meet at midpoints. Okay, diagonals meet at. So ये area का क्या formula होता है? Area का formula होता है base into height. What are base and height for a parallelogram? Let's draw this again and see what base and height for a parallelogram is. If you call this the base, then you can draw the height vertically यहाँ पे, or you can also draw it यहाँ पे. सही. One important part is that each of these 4 triangles have equal areas. Okay. Okay. Why did I do parallelogram first? Because square, rectangle, and rhombus are all special types of parallelograms. Okay, this is a rectangle. So what I'm going to write is I'm going to write all properties of parallelogram. So yeah, there are some additional properties. All angles are 90 degrees. So yeah, okay, there's one property that I missed on the parallelogram, is that adjacent angles or supplementary. Okay, which means that if this is x, this is y, then x plus y must equal 180. Okay, if there are any questions in the middle, please ask. All angles are 90 degrees and diagonals are equal in length. Okay, if I were to draw the diagonals. One side is called the length, the other is called the width. Either can be called the length or the width. Area has the formula length into width, so L into W. There is a formula for perimeter. Perimeter is the outer boundary, so 2L plus W. And there's a formula for the diagonal as well. The diagonal is the root of L square plus W square, which is basically the Pythagoras theorem applied. Okay, it's going to be useful for you to remember the formulas. Okay, then I have more space here. Okay, now the third shape that I'm going to draw for you is the rhombus. A rhombus is somewhat like a parallelogram, but it has equal sides. Okay, that's as accurate as I can draw this to be. So it's like a parallelogram, so I'm going to write all properties of the parallelogram. So yeah, what other properties does it have? All sides are equal. So yeah, and the diagonal of these of a rhombus, the diagonals of a rhombus are diagonals of a rhombus meet at 90 degrees and cut each other in half, which means that they are perpendicular bisectors of each other. Okay, what's the area of a rhombus? Either I can call it base into height, or the better formula that you will sometimes come across is that area of a rhombus is diagonal 1 into diagonal 2 divided by 2. Okay, now the last shape that I have is a square. Okay, what is a square? It's made up of all the properties. So all properties of parallelogram, all properties of rectangle, all properties of rhombus. Okay, what's the area? If I call this side S, then the area is S square. What's perimeter? It's 4 times S. What's the diagonal? It's root of S square plus S square, which is, if you simplify this, it becomes S root 2. Okay, that's an easier way of remembering it. Okay, so all sides equal 90 degrees and so on. Diagonals meet at 90 degrees and so on. Okay, the next shape that you usually come across is a trapezium. Okay, a trapezium has one pair of parallel sides. It's different from the other shapes. One pair of parallel sides. So yeah, so the area of a trapezium is then, but there's one thing that I want to tell you here, and that often comes up. Adjacent angles are just supplementary. Adjacent angles are supplementary, which means that this angle and this angle will add up to 180, or this angle and this angle will also add up to 180. Okay. Okay. What's the area? It's half into height. Height is what? Height is the distance between the parallel sides. So this is height, I don't know if I've drawn this correctly, but this is height into sum of parallel sides. Sum of parallel sides. Okay, those are the shapes that you come across. Then you come across the circle. Okay, what is a circle? A circle is a set of well-defined points equidistant from a center O. So yeah, it's crucial that you know what O is. This is called the radius. If I draw a line like that, it's called the diameter. The diameter is 2 times radius. The area of a circle is pi r square. Paper 2 asks you to take pi as 3.142. Okay, circumference of a circle. Circumference is the boundary. Is 2 pi r or pi d, pi times d. Then when you split open the circle, if I draw a circle and if I draw 2 radii, okay, this is what I call a sector. Sector of a circle. Okay, a sector of a circle is made up of 2 radii and an arc length. Okay, what's the formula for arc length? The arc equals to theta over 360 into 2 pi r. What's the area of a sector? Area of a sector is theta over 360 into pi r square. You need to remember all these formulas for your exam. So yeah, it's wise to remember the formulas. If you don't, some of you are used to constructing the formulas, which is absolutely fine with me. But when you're doing an exam, it's sometimes quicker to just remember it and apply it. Okay. Okay. Now, one thing that I did not do was segment of a circle. Sorry, not segment of a circle. Segment of a circle we'll talk about later. I didn't talk about triangles because I thought triangles should come up in trigonometry, but I just remembered that there might be questions on that. So if this is the angle theta and I label these sides as A and B, then the area of triangle is basically half into A into B into sine of theta or sine of C. You must have done C, which is the capital C. Okay, the capital C. So it's basically the sine of the inclusive angle of the two sides into half. That gives you the area. The area of a triangle also has another formula called half base into height. And height is always the perpendicular distance from the top vertex to the base. I'm not drawing that right here. We'll look at it in questions. Okay, that's all 2D shapes. Let's talk about 3D shapes. The first 3D shape that I want to draw for you is a cube. A cube is made up of made up of squares on all sides, so all these sides are equal in length. So yeah, when you study 3D shapes, you study two things. You first study volume. So yeah, volume is S cube. You study surface area, which is 6S square. Why is it 6S square? Because each side is a square and there are 6 faces. Okay, there are 6 faces for the cube. Therefore, the surface area is 6S square. There's something called the diagonal of a cube, and we'll talk about it later on. and that's root of s square, and s square. Okay. The second shape that I want to show you is a cuboid. Any questions so far? I'm writing down a lot of formulas. I'm going to send this PDF to you later on. You can have the set of formulas in front of you. Abhi will go just keep going back and forth and scroll and do things that way. Okay. Cube में length, width and height होती है. So the volume is LWH. Surface area is two times LW, LH, and WH. It's basically the sum of all faces. Okay, and this is what I call a closed cuboid, not an open cuboid, but a closed one. Okay. Just wait a moment. Okay. Third is a cylinder. Oh God. How did I go? Okay, let's draw this. Okay, so this is what a cylinder looks like. Okay, it has a circle as the base. This is what I call the height, or sometimes when it's lying down, it's the length, height, or the length. Let's write down height slash length. Okay, this is the radius of the base. There's volume, which is pi r square h, and this is surface area. Okay, surface area is 2 pi r h plus 2 pi r square. Here it's important to mention that this is what we call the curved surface area of a cylinder. This is what? This is the base and the lid. Sometimes it's open, you're going to subtract one of these. Okay? Okay. So the three types of 3D shapes that I've drawn right now are all examples of what we call prisms. Okay, prisms क्या होते हैं? Anything that can be broken down and presented as identical slices. कि अगर मैं इसके slices बनाना शुरू करूं तो identical slices आएंगे. I'm just drawing a few prisms for you. Okay, just to show you what prisms look like. Okay, this is a prism. Okay, why is this a prism? Because when I'm going to make identical slices out of it, I'm going to get this shape. Okay, this is another prism. What I've seen in the recent past papers is that the examiner tests this more often than the others. Okay, other concepts are इतने ज़्यादा दूसरे shapes नहीं नजर आ रहे, इतने prisms नजर आ रहे. Oh God. Okay, so this is another prism. इसका slice कैसा बनेगा? ऐसा बनेगा. Sometimes the prisms can be in ये सारे length में पड़े हुए. This is the length. This is also the length of a prism. Sometimes the prisms can be in height as well. Okay, this is a prism that's perpendicular in terms of. Okay, so this is in height. Although it has, this follows the same idea though. It has identical slices of triangles. Okay, if you notice all these other shapes as well, this will turn up into square slices. This will give you rectangular slices. This will give you circle slices. Okay, so all these are examples of prisms, but it's better to remember their precise formulas when you're talking about a volume of a prism. Now make sure that you know these formulas. They're very important. Area of cross section into length or height. So ये depend करता है कि length है या height है. What is a cross section? A cross section is the identical slice that you've derived. Okay. So I've been just working on half the page. That's weird because I'm zoomed in so much. Okay. Okay, so the volume of is area of cross section into length or height. Okay, let me put a bracket on that. Let me put a bracket on that as well. What is the surface area of a prism? Does anyone have any idea? It's the perimeter of cross section into height or length plus 2 times the area of cross section. Okay. If you don't know this formula, please make sure that you write it down somewhere. This is something. This is probably the most important part that I'm going to teach you right now, and I want everybody to be well versed in it. Okay. Next page. Okay. Well, in fact, I have some space here. I don't need another page. Let me draw a cone for you. Okay. This is called the slant height. This is called H, and this is R. Okay, what's the volume? Now, some of these formulas are provided to you on the exam as well, but again, it's better to remember all of them. 1/3 pi r square H, surface area, pi r L plus pi r square. This is what? This is the curved area, and the base. Okay. Pyramids can take various forms. Okay, because you can have various pyramids. The volume is 1/3 base area into height. Okay. Okay, I think we should move on to questions now. Let's see what is there in the question. Some are two-dimensional, some are three-dimensional. So yeah, I would encourage if some of you could sit down with a calculator and help me calculate some things as I go on. So here, take pi to be always 3.142. Okay, it says OAB is the sector of a circle, center O and radius 10, AOB, and C is the point on the arc AB such that OC bisects AOB. So what I have divided this up into is 36 and 36. Calculate the perimeter of sector OAB. Okay, when I'm asking you for the perimeter of the sector, I'm asking you for all the boundaries. So I have to calculate the arc length and I have to add 2 radius to it. So I'm going to say arc length, the entire sector. So I'm going to say 72 over 360 into pi, 2 pi r, sorry, 2 pi r. 2 pi and r. Okay, what do I get? 12.568. Okay, and if I want to calculate the perimeter, I will do what? I will add the 2 radius to it. That will give me the entire boundary. Okay, that is 32.568, and I'll write this as 32.6. Calculate the area of sector OAB. So here, if I want to calculate the area of the sector, again, it's a simple formula. Area of OAB is 72 over 360 into pi r square. 6.28. What did you write as 6.28? Have I done some calculation wrong here? Or are you telling me the area? $62.8. Yeah, 62.8. Okay. Let's just calculate the total shaded area. Now remember that you calculated this entire sector. You calculated the entire sector. Okay. If you remove these two triangles, you will automatically end up with the shaded area. Now, whenever you are doing this question with triangles, remember that you always end up using the formula half AB sine C. So in this case, the area of triangles is half A B sine of, I can take one angle at a time. That's going to be necessary because these are two different triangles. I can't just say that it's sine 72, else the answer is going to be wrong. Okay, because I'm talking about one triangle. One triangle is made up of 36 degrees only. Okay, you're going to get the wrong answer if you multiply it by sine 72. I'm getting 29.389. So what am I going to do? I'm going to say that area of shaded region is 62.8 minus 2 times 29.389. Okay, makes sense. Any questions? It's okay, beta. Just I think I'll upload this later up later on YouTube. You can find that there. Okay. This is something interesting. It says D is the point on the arc AB such that AOD and DOB are divided in the ratio 1:2. So let me see what they are talking about. I want to divide this angle into the ratio 1:2. So I'm going to do this. That 1/3 of 72 gives me 24, and 2/3 gives me 48. So instead of a 36 divide, now I've done this. He says that Gavin says that the shaded area on the diagram is the same as the shaded area calculated in part B. Okay. Okay. So if I look at my previous question, my sector hasn't changed. Okay. So I'm going to take this one. I'm going to say 62.84. Area of sector is still 62.84. What has changed is what the triangles that I had. Okay. Triangle 1 and triangle 2. These are the ones that have changed. Okay. One has grown while the other has shrunk. Okay. So I'm going to say area of triangle 1 is half. I still have the same sides, 10 by 10, but I have a different angle to calculate, work with. Sine of 24. Area of triangle 2. Okay, 37.157. Okay, now let's check. Shaded. Okay, you see the amount of working that I'm doing. It's essential that you do the same amount of working that I have been doing, because the examiner will look for these steps. Okay, 5.34. Is he correct or is he wrong? He's wrong, right? He's wrong. He's wrong. Shaded area has increased. Does that make sense to everybody? Okay. Sarah, just make sure that you're not doing a premature approximation in terms of writing this as 37.15. It's actually 37.16 if you want to write it. Okay. I would write more decimal numbers here and then round them off at the end. That's what the examiner wants you to do. Okay. So two-dimensional question, not a very difficult question, and easy, sort of 7 and 5, 12 marks. I don't think that was a difficult question at all. Okay, let's look at this mensuration question. I've given you the volume of a cone. I've given you the curved surface area of a cone. I forgot to write sphere and surface area of sphere earlier on. Let me see if I can write that somewhere. That's what I forgot. I was thinking what I was missing out. Let me just write that here. Sphere, volume, surface area is 4 pi r square. So that your notes are complete. Okay. Okay, coming back to this question. It says the diagram shows a solid A which is made from a hemisphere joined to a cone of an equal radius. So they've joined it at this point. The hemisphere and the cone are each have a radius of 6. So this side is 6. Okay, this is 6. Okay, the total height of the solid is 18. Okay, So if this is 6, automatically the radius here is also 6. They've already told you that. Even if they hadn't told you, you would know that this has to be 6. Show that the slant height of the cone is this. Okay, so remember that slant height is always found by the Pythagoras theorem. So I'm going to say that x square equals to, this is 12. So 12 square plus 6 square. X is therefore the root of 144 plus 36. 180. Root of 180. Okay, so 13.4. Then it says calculate the total surface area of solid A. Okay, the solid A is the entire solid. It's not just one part of the solid, it's entire solid. Okay, so I'm going to say that the total surface area of solid A. Remember that only when I'm talking about the surface area, only the curved surface area of the cone is visible. So I'm going to say curved surface area of a cone. Area of a cone. That gives me pi RL. So I'm going to write 3.142 into radius, which is 6, and L that I just found out to be, if I want to write it precisely, I can write it as root of 180, because I think 13.4 is rounded off a little. Okay, so I'm going to write the exact one, and I'm going to say that I have 252.926. Then I'm going to say that curved surface area of hemisphere. Okay, and that is going to be pi r square. 4 pi r square divided by 2. Sorry, 4 pi r square divided by 2. Okay, because the complete surface area of a sphere is 4 pi r square. Since I have a hemisphere, I'm going to divide by 2. I'm going to say that this becomes 2 into 3.142 into 6 square. 226.2. Okay, total 479.15, which is approximately equals to 479 when I round off to 3 significant figures. Okay, nothing difficult about it so far, is there? See, the trick about mensuration questions is remembering formulas. As long as you remember formulas, you should be fine. And it says volume of solid A. Again, I'm going to calculate the volume of the cone. I'm going to say 1/3 pi r square h, 1/3 3.142 6 squared, and h is, let's see the h. I think that was 12. 12. So I get 3.142 into 36 into 12 divided by 2. I'm getting 678.672. Volume of hemisphere. The full volume is 4/3, so I'm going to say that half of 4/3, pi r cube. So half of 4/3, 3.142, 6 cube. Okay, total. Okay, rounded off to three significant figures, 1130. Okay, so far so good. I've gotten an easy 8 marks out of this, just applying basic formulas. It says solid A is one set of three geometrical similar solids A, B, and C. Now they're geometrically similar. That means there must be a ratio. The ratio of the heights is 2 to 6 to 1. Calculate the surface area of solid B correct to three significant figures. If the ratio of heights is 2 is to 6 is to 1, do you understand that the ratio of areas is 2 square to 6 square to 1 square, which means that A, B, and C have the ratio of areas as 4, 36, and 1. If I found out the area of A, can I say that it's 479? And I'm going to put an X here. I'm going to ignore C for now, and I'm going to cross multiply and see what I get. Okay, the answer that I'm getting is 4311. Does everybody understand that? If the ratio of areas heights was 2 is to 6 is to 1, then the ratio of areas must be 2 square to 6 square to 1 square. Then it says calculate the volume of solid C. What must be the volume of ratio of volumes? The ratio of volumes is 2 cube to 6 cube to 1 cube. I get 8 to 1 6 and 1. So A, B, C are in the ratio 8 to 1 6 and 1. What's the volume of A? 1130. So I'm going to write 1130. It's to X. Cross multiply it. Three zero five one zero. Okay. Any questions? Okay, part C. Part C, this one, volume of solid. Do you want me to do volume of solid again? The volume के formulas तो given होते हैं, ये देखो. And ये 4/3 दिया हुआ है. So what I've done is I've said volume of a cone. I've applied the simple formula that was given to me. R is 6 and height is 12 because I'm just considering the cone. Then volume of hemisphere. So I've taken the entire sphere and made it half. I've taken half of this. So I'm getting this. And then I've added the two to get this. Okay. I just applied the formulas that were given to me. Okay. Now 9A. 9A says that the ventilated shaft for a tunnel is in the shape of a cylinder. We'll draw this for you. Okay, there's a cylinder. Okay. The cylinder has a radius of 0.4, so 0.4, and a length of 15. Calculate the volume of the cylinder, which is simple. Volume of cylinders has a formula, pi r square h, so 3.142 into 6 square, sorry, 6.4 square into h or length. So in this case it's the length, so I'm going to call that the height. Okay, what do I get? I get 3.142 into 0.4 square into 15. That gives me 7.54. Okay, then this is something different. It says that the diagram shows the cross section of the tunnel. So the tunnel was flat at the bottom. पहले नहीं लिखा था, अब लिखा हुआ है. The tunnel itself is flat at the bottom. So if you were to see this, you would see this as a complete circle. And draw a coordinate circle for you. So अगर ये complete होता तो ये ऐसा होता. Okay? I don't know. It's messing it up. Yeah, ऐसा होता complete circle. Okay. It says the cross section of the tunnel is a major segment of a circle center O. The radius of the circle is 4.5 and AOB is 110 degrees. Calculate the area of the cross section of the tunnel. So I'm asking you for this entire area. I'm asking you for this entire area. Do you understand that the area of this cross section will be area of major sector plus the area of the triangle? Okay, because this is the major sector, this is the sector that I'm talking about, and this is the triangle that I'm talking about. If I want to find the entire area, I have to find these two separately. So I'm going to say that area of major sector is, if I'm talking about the major sector, I need this outer angle as well. What is this outer angle? This outer angle is 360 minus 110, which is 250. So 250 over 360 into pi r square plus area of triangle half A B into sine of 110. Does everybody understand the calculations that I've done? Any confusions or anything that's bothering you? Please tell me now. $44.18. Okay. Have I done a calculation mistake? Are my calculations correct? Can somebody check? I don't know if my calculations are correct. I want you guys to check. Okay, I want to do one last question with you, and I want to do something with a prism, and then we're going to do more questions tomorrow in the class. I want to do this one with you. Okay. 52 are the answer. I don't know. I might have made a calculation mistake somewhere. Okay, I'm checking. Okay, I'm gonna divide by 2 नहीं किया था, my bad. So 53.7. Thank you. I made a mistake. Okay, I wanted to show you that one with the prism. The diagram shows a garden shed positioned on horizontal ground. It is in the shape of a prism with trapezium ABCD as its cross section. The base of the shed ABFE is a rectangle. AB is equals to this, AD is equals to that, and so on. So I have a lot of dimensions given to me. It says calculate the volume of the shed. Can someone tell me what shape this is? What shape am I talking about when I want to find the volume of the prism? Volume, it says, in fact, it says it's a prism. Why am I asking you that then? Okay, if it says volume of a prism, and the cross section is a trapezium, so I'm going to say that the volume of prism is area of cross section into length. Okay, let's talk about area of cross section first. It's a trapezium. So I'm going to say that it is half into height into sum of parallel sides. Okay, some of you are confused about height and sum of parallel sides. So let's decide what the parallel sides are first. Everybody will agree that these are the parallel sides. So this must be the height. It's just that it's placed differently. This trapezium is appearing differently to you. So I'm going to say half 1.55 2.25 plus 1.85. There are other ways of writing down this formula as well. Sometimes it's written as half into parallel sides into the distance between the parallel sides, which is also a good way of sort of remembering the formula. I'm getting 3.226. So volume आ जाएगा 3.226 multiplied by 2.10. Okay, I'm getting 6.77. 6.77. Okay, is that correct? Okay. Now it says the roof CGHT is painted. 1 liter of paint covers 2 square meters. Calculate the amount of paint used. Now, what shape is the roof? Who can tell me what this CDHD is? HG. What shape am I talking about? It's rectangular. Yes, it's rectangular. You're absolutely right. That's basically a rectangle. So rectangle का area क्या होता था? It was just length into width, right? Okay. Width is 2.10. I'm fine with that. What about the length? Do you know the length? Why it's not a rhombus? It is a rectangular. घर की जो छत होती है वो आप स्लांट करके लगा दें रहेगी तो वो रेक्टेंगल ही ना. ये आप सोचिए घर की छत थी यूं पहले लगी हुई थी हॉरिजॉन्टली और फिर आपने उसको स्लांट कर दिया रहेगी तो वो रेक्टेंगल ही. ओके okay, who can tell me how to calculate this length? Any ideas about the length? Because that's what this question is really about. No? No ideas? Let me just tell you then. Let's see. You don't need to find the perimeter. Perimeter तो तब निकालना होता जब total surface area चाहिए होता. अभी तो मुझे सिर्फ छत का surface area चाहिए ना. Let's say ये E, F, G, H. ये मैंने आपके लिए cross section draw कर दिया है. Okay? मुझे H, G की length चाहिए ना. That's what I'm looking for. So I've drawn the cross section for you. Okay. Okay, ये मैंने आपके लिए क्रॉस सेक्शन बना दिया. अब बताओ ये कैसे निकालूं? How do I calculate this? Pythagoras use करूं Maria? How? I don't have a right triangle right now. Can I draw a line from here to here? And say that this line is also going to be 1.55. And this length that I have will be 2.25 minus 1.85, which is 0.4. Can I then use Pythagoras? क्या मैं अब कह सकता हूँ कि hg squared equals to 0.4 squared plus 1.55 squared. .56. Okay, I have 2.56. So I have hg now, which is my length. I have my width as 2.10. So the area is 2.56 into 2.10. What does that give me? 1.6. अच्छा मैंने रूट नहीं किया, सॉरी मैंने रूट नहीं किया, my bad. 1.6. 1.6 into 2.10. 3.36. Okay, 3.36. So 1 liter of paint covers 2 square meters. So 3.2 square meters. So 3.36 cover करने के लिए कितना चाहिए होगा? That gives me 3.36 divided by 2, 1.68. Does that make sense? Okay. Last question quickly. It's the angle of elevation. It's a trigonometry question, not technically mensuration question. Angle of elevation of D from F. Okay, I am looking at D from F. So my line of sight is basically FD. My height is 2.25 and I'm looking on this line of the ground at FA. So what I'm going to do is I'm first going to draw this for you. I'm going to say that whenever you want to calculate the angle of elevation, you should draw a right triangle F D and A. That is what I want to find out. AD is 2.25, that I'm clear about. If I want to find FA and I want to find this angle, okay, how do I find FA? For FA, I can use this triangle at the bottom and say that FA squared would be 1.55 squared plus 2.10 squared. .61. Okay, and then I'm going to use tan and I'm going to say that's opposite over the adjacent, and I get my answer. I get 40.76, which is 40.8. Okay. Any questions at this point? I think I want to stop here today, and I will pick it up back from here in the next class, do more questions with you, show you all the different situations that you might have on the exam, and